I am Mohammed Kaif from Mechanical Engineering 2K19 batch, roll number 298, and I am presenting you the application of computer and IT in the field of wind energy. Basic concept of wind energy. Wind has the energy in form of kinetic energy which can be harvested to produce electrical energy by the use of generator turbine. The main factors responsible for wind are unequal heating and cooling of ground surface because of solar radiation and rotation of earth about its own axis. Chronology of conversion of wind energy to useful power. First of all, kinetic energy of wind is used by wind turbine to rotate, which means that the kinetic energy of wind is converted into mechanical power, and this mechanical power is used to rotate the turbine, and the generator which is connected to the shaft of the turbine use it to convert it into electrical power. Application of computer software in this field of wind energy. Specialized wind energy software applications aid in development and operation of wind farms. Specialized work in wind energy farming include pre-feasibility and feasibility analysis, turbine design, flow modeling, farm visualization, farm monitoring, and prediction software. Pre-feasibility and feasibility analysis. The RET screen software wind power model is designed to evaluate energy production and saving cost, emission reduction, financial viability, and risk for center grid, isolated grid, and off-grid wind energy product. For multi-turbine and single-turbine hybrid system developed by the Government of Canada, the software is free, multilingual, and include links to wind energy resource maps. The wind data generator is wind energy software capable of running WRF weather research and forecasting model to create wind atlas and generate wind data at resolution of 3 kilometers to 10 kilometers. Turbine design software helps design wind turbines. These are several aeroelastic packages that are used in design process. FOCUS6 aids in design of turbine and turbine components such as rotor blades. It was developed by Knowledge Center, Wind Turbine Material and Construction and Energy Research Center of Netherlands. The National Wind Technology Center, a division of US National Renewable Energy Laboratory, has developed many packages which are used by turbine manufacturers and researchers. NWTC has developed a suite of turbine design and performance prediction code which rely on blade element momentum theory. WT-PERF uses steady BEM theory to model turbine performance. FAST is a comprehensive aeroelastic simulator which use unsteady BEM theory model a turbine as a collection of rigid and flexible bodies in spatio-temporal field of turbulent flow. German Cedar Lloyd found fast suitable for the calculation of onshore wind turbine loads and for design and certification. The open software kubelet developed by Wind Energy Research Group of Hermann Fottinger Institute of TU Berlin is a BEM code coupled with aerofoil simulation code. It allows the users to develop, import airfoils, simulate them, and use them for design and simulation of wind turbine rotors which use steady state BEM theory. The software is built with the Qt framework, thus it includes graphical user interface. The open source software Voltage developed by Bayern Hinz GmbH in Berlin is unsteady 3D panel method implementation suitable for dynamic simulation of vertical and horizontal axis wind turbine easily coupled with other simulation environments such as Simulic and Dymola. It is suitable for aerodynamic optimization, field structure interaction problem, and unsteady control system stimulation. SS is a software package for analyzing aerodynamic and mechanical force for onshore and offshore horizontal axis wind turbine. It is based on research done at Norwegian University of Science and Technology in Trondheim, Norway. Here is the list of some turbine design engineering softwares. See it and analyze it yourself. Flow modeling. Wind flow modeling software predict important and wind characteristic at location where measurement are not available. Furrow is a software which offers a linear flow model and a computational fluid dynamic model in the same software. WASP was created at Denmark Rizzo National Laboratory. WASP use a potential flow model to predict how wind flow over a terrain at a site. Metadone, WT, Windy, WindSim, Wind Station, and the open source code Cephi tools are used in computational fluid dynamics instead, which are potentially more accurate but computationally intense. Here is a list of some flow modeling softwares you can use it, analyze it, and rate it to yourself. Farm modeling. This software simulates wind farm behavior. Most importantly, to calculate its energy input, the user can usually input wind data, height and roughness, contour lines, topography, turbine specification, background map, and define environmental restrictions. Processing this information produces a design of wind farm that maximizes energy production while accounting for restriction and construction issues. Packages include Furrow, Metadine, WT, OpenWind, Wind Farm, Wind Farmer, Analyst, Wind Pro, WindSim, and WindStation. Farm visualization. Wind farm visualization software graphically present a proposed wind farm, most importantly for purpose of obtaining building permits. The primary technique includes photo montages, zone of visualization, visual impact maps, and three-dimensional visualization. Perspective views of landscape, often incorporating aerial photography and include turbines and other objects. Here is a list of some fun visualization software which you can use. Farm monitoring. Wind farm monitoring software is a software that allows people to see if wind turbines are running well or are going to become broken. Other function of monitoring software is reporting, analysis of measured data, power curve, and tool for monitoring of environmental constraint, i.e. bat control, etc. Here is a list of some farm monitoring software which you can see it yourself. Prediction software for existing wind farms. Several software systems exist which produce short and medium term forecasts for generated power, single farm or complete forecast region using existing numerical weather projection data and WP and live SCADA farm as input. Examples of numerical weather prediction model used for purpose are European Hill-Ram High Resolution Limited Area Model and GFS Global Forecast System from OAE.